Good morning or good afternoon, everyone, depending on where you're joining us from, and welcome to today's webinar. My name is William Dewig from Business Review, and I will be your host. It is our pleasure to have the Sniffers with us today, who will be discussing the latest practices and results for tank management. Today's guest speakers are Leen van Brandt, R&D Team Leader, and Bas Hermans, ED Operations Director. I'd like to welcome you to our webinar platform on 24. You'll notice that this webinar is browser-based, so if you do disconnect for any reason, please just click on the link that you received via email to rejoin the session. In order to ask questions, you can send them in via the questions widget. Just type them into the box at the top left-hand corner of your screen and click submit. We'll allocate around 10 to 15 minutes at the end of the session to address any questions or thoughts that you may have. At the end of today's session, a survey will appear in its place, and we'd appreciate it if you could take the time to answer the questions provided. Please use the yellow help widget if you require any assistance, and you can move, resize, and maximize any of the windows in front of you to get a better view of the slides. But now, please allow me to welcome Leen.
Dear audience, welcome to this webinar of the Sniffers, in which we will focus on tank inspection. The Sniffers are active in different areas, such as pipeline integrity, energy savings, and emission reduction. It is in this last domain, emission reduction, that today's presentation is situated. Within the emission reduction part, optical gas imaging is just one area. Optical gas imaging means that an infrared camera is used to perform gas leak detection. The camera makes it possible to really visualize the gas as a cloud. This provides visual evidence, and it also makes it possible to detect large leaks quickly. The camera is also often used to perform a quick scan after shutdown to quickly detect incomplete repair or inaccuracies. What is the principle of OGI, or optical gas imaging? Our camera, the camera of the Sniffers, detects volatile organic compounds, or VOC. Most VOC absorb infrared waves. Certain wavelengths are absorbed more than others, and that's what the principle of the camera is based on. pH bonds of organic molecules have a large absorption band with high intensity around 3 to 5 micrometers. As such, this is an important wavelength window for organical compounds which are found in refineries and chemical companies. The filter of the camera only transmits this region of the electromagnetic spectrum. It is exactly because a certain part of the infrared radiation of the background is absorbed by the gas cloud that a difference is created between the background and the gas cloud. This difference makes the leaks visible. As such, the gas leaks are visualized by the camera as dark or white clouds. Here you can see a schematic representation of this principle. We have the gas leak against the background. The gas leak absorbs certain wavelengths from the background. That creates a difference between the leak and its surroundings. So we see this difference between what was there and what is left due to the absorption by the leak. Sniffers tank inspections mostly comprise of a combination of flame ionization detection, optical gas imaging, and also a technique called high-flow sampling, which is actually a technique based on tagging. In the past, there were no real guidelines for the use of the camera, but recently a team sat together in the Netherlands and constructed the so-called NTA A399. NTA stands for Nederlands Technische Afspraak, which is in English Dutch Technical Guidelines. The NTA A399 is a guideline for detection of diffuse fog leaks with OGI. So it explains how the camera should be used in practice when you go to the field. It is actually not specific for tank inspection, but in the attachment it focuses on tank inspection, and it also gives an example for a tank inspection form. The Sniffers follow these guidelines during their tank inspection programs. So the NTA A399 are guidelines for detection of diffuse fog emissions with optical gas imaging, OGI. It focuses on portable, passive optical camera systems visualizing fog in real time. Safety, environment, and loss of product are main driving forces for the application of OGI, and it is important to stress that it is a qualitative approach, not quantitative. Advantages of OGI on storage tanks are reduced monitoring time. You can quickly monitor several tanks, especially compared to FID monitoring, such as sniffering. You have images of registration, including date and time, which includes a provability factor. You can also review emission indications at unexpected locations. And there is also an important health factor, because you can monitor from a distance. So how is this Sniffers Tank inspection program constructed? In the preparation phase, we request for location plan of the tanks. We request for the products that are present in the tanks at the time of the measurement and also the safety data sheets. And we check whether products are measurable by OGI. So if they can be detected by the camera. We do this by looking for a spectrum of the compounds of interest in the NIST database on the internet. And we look at the window of the filter of the camera, which is between 3 to 5 micrometers. So we look if there is a strong absorption band. If that is the case, it is likely, very likely, that the compound will be detectable with the camera. How is the program executed? The tanks that are part of the scope are screened by checking all possible emission sources with the camera. When no emission indications are observed, an overview video of the tank is made of the tank roof in 3 different modi, namely the visual mode, just a movie, the normal infrared mode, and also the high sensitivity mode, which is very difficult to look at, but which makes the leak very clearly visible. When an emission indication is observed, also videos are made of this emission in the 3 different modi. Emission indications are evaluated, whether they are normal or not. All images are included in the report. Overviews of tanks with no emission indications, as well as individual videos of emission indications. After repair, the emission indications which were found earlier are rescreened and new videos are recorded. This is an example of a tank inspection form. The blue cells contain information that is collected in the preparation phase, so before the actual project. In the green cells, information is collected during the project, so on site. On this form, all the information is also collected about the sources that were screened, and it is indicated if they showed emissions or not. On this form, also, it is indicated which movies correspond to which emissions, and which sources which didn't show emissions. Now I am briefly going to show some study cases, mainly roof inspections. Here is an example of a project which we have performed. On this tank inspection form, you can see that 5 sources were screened, and only 1 showed an emission indication, which was the red dot on the inspection form. This was a deck leg, and this is the one that is pointed towards on the pictures. Here, a clear emission is shown of an equipment on a tank. These are the type of videos that we will provide together with the report. and the names of the files are indicated on the tank inspection forms. On this video, it is clearly visible that the tank shell is leaking. You see the white clouds disappearing from the tank shell. In another case study, we checked the working and efficiency of a breather valve. We first measured this breathing valve with an FID, and we got the profile which is shown in the slide. And this is not a properly working breather valve. The emission was also shown on an infrared video, which will be shown in the next slide. And we saw that after repair of this breathing valve, the breather valve was only emitting when it was opening. Also, floating roofs can be inspected with the camera without a problem. Here, different equipment types are shown. It is best if the tank can be, if we can go on the tank, but if it's not possible, it's easy to indicate emissions from the platform.
What we see here is the roof, and it's welded to each other. And what you clearly can see is that the welding is leaking. So again, we see that the optical gas imaging camera is a very, very powerful tool to detect the leaks. What happens is that with the camera, you can do a fast screening on your tanks, and you can immediately spot a lot of leaks and a lot of indication of problems. This, for example, is a hatch of a floating roof. So it's like a floating container that's keeping the roof above the liquid. And what you see here is that normally it should not leak, but with the camera you can see immediately that it's leaking. This is what we call the high sensitive mode. We always film in 3 modes: the visual, the normal, and the high sensitivity mode. What we see here is again a sealing of a tank. Again, we see the normal picture. We don't see any leaks. Now we're screening in the normal modes. We see a cloud coming up, like small leakages, and then we see the high sensitive mode, what makes much better and much more fine-tuned to find leaks on tanks. So here we see nicely a smaller leak on sealing of a tank, of a floating roof tank.
In this study case, we walked around the tank with a flame ionization detector, and at a certain point we clearly saw an elevation of the concentrations on the FID, so which meant that there was an emission coming from the seal of the tank. Looking with the camera at the same point, we got a clear image of how bad this emission was, which will be shown in the next video. Here it is. In the next video, we will see a tank with a huge problem, but there was a reason for this. Some time ago, a truck was burning next to the tank, and it deformed the tank shell. But we observed that when the tank roof was at a certain height, there was no problem, but at another height, a huge emission was coming from the tank. After the OGI, I will focus on high volume sampling or high flow sampling. This is a technique based on bagging, but the difference with vacuum bagging is that in high flow sampling, a flow is created which gently sucks the surroundings of the leaking equipment through the instrument. Mostly this technique is used after leak detection. It's not a leak detection technique because it takes too long to detect all the leaks, but it is mostly used to quantify the leaks after leak detection. The added value of high flow sampling is that losses can be calculated for each leaking component separately, and it is possible to calculate exact emission of tanks with floating roofs and fixed roofs. The method is as follows. After bagging the equipment, the leaking gas is drawn through the instrument together with some surrounding air at a certain known flow. This flow is set on the instrument, and it is important that this flow is known to be able to calculate the exact emission afterwards. So the gas leak is drawn through the instrument, and at the exhaust of the instrument we measure the concentration with a flame ionization detector. This is the setup of such a measurement on a tank. We see that an equipment is bagged on the tank. The high flow sampler is attached with a hose to the bag. The surroundings of the leak are drawn through the instrument, and you can see that the FID detector is attached to the instrument and measuring the concentration at the exhaust. The lower part of this image shows that we also have a solution to measure mass emissions from the tank seal. So if the tank seal has a problem, we can measure how much kilograms is escaping from the tank. If you only want to know volume-based emission losses, you can multiply the total flow which you have set on the instrument with the concentration fraction of the gas measured at the exhaust of the instrument. If you want to know mass emission, you have to multiply this volume-based emission with the density of the gas. Knowing the components which are in the vapors, you know the molecular weight, and it is easy to calculate the density. Having calculated all these details, we provide you such a report, giving you for each equipment on the tank the exact mass emission which is escaping from your tank. I thank you for your attention.
So welcome, my name is Bas Hermans. I am the Energy Saving Director of the Sniffers, and I will be taking over this presentation. So I will be telling you something about energy savings on tanks. So what are the services that the Sniffers provides for energy saving services on tanks? Well, first of all, steam loss management. We have a full program to manage your steam loss and to help you reduce your steam losses in your tank farm. Flare loss management. We have a full program again also for the flare or vent losses in the tank farm, especially for natural gas or ethylene or lighter gases. Further, we have thermographic integrity inspections, so we do all kinds of infrared monitoring to detect level in the tanks, insulation problems, all kinds of hotspots monitoring. And of course, also we have a program for compressed air and vacuum leak detection, and also nitrogen losses. So it's a specialized ultrasound monitoring to detect all your losses in your tank farm. Of course, for every service we deliver, we have a specialized and self-built software. Everything is built in SQL, so professional, and it has no limits of data. We're going to start with steam losses in a tank farm. So what are steam losses? Well, steam losses are caused by defective steam traps, bypasses, process valves that start discharging. all kinds of visual leaks coming from all kinds of steam lines. So what we're trying to do is make as full and complete monitoring program to manage your steam losses in your plants. So what kind of equipment are we using? Well, we are combining three techniques, three different equipments. First of all, we use the ultrasound measurements. The best way to measure a steam trap is definitely ultrasound. Easy and fast to detect internal leaks of your steam trap or your bypasses. And it makes it also possible to do a quantification. So we know what kind of type of steam trap it is. We know the technical specifications of the orifice in the steam trap. We know the pressure on the steam line. We know what is the type of steam trap, and so we can calculate the exact loss on the steam trap when it's defects, when it's leaking. So this is the reason why we use this ultrasound measurements. We combine it always with temperature. We use an infrared pyrometer, and of course it gives you indication if the steam trap is cold, hot. And further, also we use a thermal camera, and the thermal camera is an extra addition. It's like a visual proof to see if there's anywhere open bypasses in the plant. So steam traps have bypasses or larger bypasses in the process system, but also condensate lines, if they're blocked. We can screen for certain heat exchangers with steam. So all kinds of process screening and analyzing is covered. So how do we start a program? Well, first of all, we come to your site, we collect all the data, we collect all the PNADs of all the steam traps. We make a calculation, we make an identification, and then we start in the field. So every steam trap that we spot gets a full inventory, what kind of steam trap it is, so all the information to calculate the losses. Of course, we do tagging of the steam traps, we take pictures of the steam traps, and of course, everything is being marked on a flat ground plan or a plot plan, like we call it. So afterwards, when you have a steam trap with a unique number, you can find it very easily back. You have the picture, the flat ground plan, all the information you need to recover your steam trap. Then we do the measurements. We also do measurements on the condensate line. We check if your condensate line doesn't have enough back pressure, for example. We see typical in refineries or larger plants that it's possible to have a high back pressure, what makes it possible that a lot of steam traps are not working correctly. Then, of course, the data is going to the software, and everything is calculated and given to you as a handover. Here in the next slide, we see a case study. This is about a tank farm, and it's a tank farm part of a refinery. So we see around 2,000 steam traps. This is pretty high for a tank farm. But again, in a refinery, you have bitumen, you have asphalt, so a lot of steam traps needed to heat the tanks. So here you had around 2,000 steam traps. And the status, if we see the statuses, you see the status okay. This means the trap is working normally. You see not okay leaking. This means that the trap, of course, is leaking. But you have even more statuses to determine the status of the traps. You have DGs like defective gaskets. This means that the trap is leaking externally through the flange. You have cold. That means that the trap is cold and not working normally. You have out of order, valve closed, fill closed, and no status possible. So if we see to this case study, we see around 2,000 traps, where from around 1,600 work normally. So around 80% is working fine. This is a quite high number. We see leaking 134 traps of the 2,000, meaning around 7% is leaking of the steam traps. And this is not a very high number. What we see generally is between 5 and 30% of leaking steam traps in a plant, according to the type of steam trap being used. Around 150 are cold, also around 7%. So this is also a high number of cold and non-working steam traps. these 2,000 steam traps, you remember that we have 134 leaking steam traps. These are causing around 9,000 tons a year of loss in the plant. So if you calculate it per steam traps, it's an average of 67 tons per leaking trap, meaning per leaking steam trap you lose around 2,000 to 3,000 euros. That's quite a high number. In this case, it was a project in Germany, and we calculated the cost around 30 euros a ton. In more larger sites, can even go up to 15 euros a ton. So expensive to make steam. You see that there's a high cost reduction here, and that's possible with the measuring of the steam traps. You also see the different steam systems. You see that the largest loss is done on the lowest pressure steam, what is normal, because 99% is from this system, so this is all normal. In the next slide, we see that we see all the traps compared by brands. And of course, I can show you a lot of graphs today, but I just picked one. The software makes it possible to make all kinds of different graphs. This one is for the comparison between brands. If your number of steam trap measured is high enough, you can compare all the brands. And you see, for example, the first brand has a leaking rate of 6.7%. The second one, 20%. So you can finally see which trap you should be using in your plant. To the financial analysis, we remember that we have around 9,000 tons a year loss. If you calculated that to financial loss, you're around 270,000 euros per year loss just by a tank farm. That's a high amount of steam loss, so a high amount of financial loss. Here we made a calculation on how fast a project repays itself within the year. We see in the first graph cost steam loss 270,000 euros. The second one is cost new traps, meaning if I had to replace the 134 traps, it would cost me around $53,000 for all the new equipment. And this is calculated on the existing type. So the software knows this type costs so much money, so we can calculate it also by the software. The maintenance cost is to replace all the traps by a maintenance department. And then the last part is the management program cost, is what the program that we are doing for the monitoring. So the whole inventory and the whole measuring campaign with full analysis and quick scan of the site was around $25,000 for 2,000 steam traps. And we see here that the payback factor around 3.2, meaning in 4 months after repair, everything is already paid back. So a high financial payback. This is a part of the quick scan with the infrared camera. What we see here is a 4-inch valve, so a very huge steam valve. On the left side, you see an inverted bucket, very large steam trap. This was coming from a reactor. When we did the screening, we saw that the bypass was leaking. So we went to the control room. We told them, okay, this bypass is leaking. And they said, no, it's not leaking. We opened it because the valve, the steam trap was too small. So you see what is already known a long time in operations. They just opened the valve of 4-inch and lost around 2,000 euros a day. What in this situation they just had to do was buy a new steam trap, a better one with a higher capacity, for example, a floating trap. And in this case, they just opened the valve because it's very easy, of course. But again, 2,000 euros a day loss in this example. In this case, also, all the remarks during the quick scan are being listed, meaning our guys are going in the field, they are doing the inventory, the monitoring, and everything what they see, what they pick up, they take pictures from it and make a movie from it, and they will report it to you directly into the report. And what we see here is a steam trap, two larger ones coming from a tank. So the tank is internally traced, then it's going to the steam trap, and then it's going to the condensate line. And the connection between the condensate line is not correctly performed, meaning normally it should go on top of it, and here it's below. So all the condensate is running downwards, coming from the condensate line to the ball flow traps that you see here, and it gives water hammering or implosions. And I will show you a movie about it. So also our guys will make a movie, and they will give it to you afterwards. So everything here is you can hear the water hammering, very fine, so you hear a very large noise. You see here the condensate line going to the steam trap, and both steam traps are leaking. They're blowing steam into the system, and you get implosion of the steam bubbles into the cold condensate. Now we look up and you see it goes directly from beneath, but normally it should go on top of the line, so that there's no condensate returning to the steam trap. So this is a bad installation, and this is one of the things that we are reporting on a daily basis when we go into the field. A very nice example in a tank farm with a larger steam trap. Again, also with the heat camera, the first what we see is also a steam trap. Again, it's blowing, so it's an inverted bucket, blowing steam into the steam in the condensate line. The condensate is cold, so again, implosions. The second one, again, is a leaking bypass. So all these problems, all these leaking bypasses, all these remarks that we make in constructions are listed and all go into the report. So you get a full report on all your problems on the steam line. And this is what we call the quick scan. Again, when everything is finished, the project is finished, you will get detailed repair orders, you get a full report, graphs, an overview, and a full analyzing of steam trap and tagging of the leaks. So everything is in the report. The second that we're going to discuss is the flare or vent losses. Well, what are flare or vent losses? Well, it's an in-turning passing of a valve. In a flare system or a vent system, you have lines between the vent or the flare and the system it protects, and normally it is closed. And for example, in a tank farm, you have a few hundred points between the flare and the tanks that it protects. And it can be that they're leaking internally, so meaning it's going to the vent or to the flare because of a leak. Normally they're closed, but in certain occasions they can leak. And this is what we are going to screen for and what we made a full program for. So we will be monitoring all different types of points between the flare and the system, and we will be monitoring with ultrasound and detecting if they're leaking or not. What are we using for this program? Well, we have the VPAC. It's an ultrasound detector. It's X-proof, so it's intrinsically safe. And then you see the picture, you see a relief valve, and one of our guys is measuring it with like a stethoscope. So he's listening to what is happening inside of the relief valve. We will monitor also upstream, we will monitor downstream to make sure that this, if it's leaking, it's coming from the relief valve, the sound, and not from a compressor nearby or any other source that could be polluting the sound. So again, also here, we make a full program. We start with a preparation. We will go to your site. We will collect all the PNIDs. We will detect all the possible flare points. We will go on site. We'll make a full inventory. We'll do the measurements, and again, you will get the report and all of the recommendations that we have for you. So what are the benefits? Why should you do it? You know where your losses are. Of course, we can say exactly it's this relief valve with number A or this control valve number B. Of course, show care about the environment. These leaks could cause huge emissions to the flare, to the stack. So again, take care about the environment. Define losses in kilogram per year per product in real money, meaning we can determine what kind of product is leaking, and we can also calculate the loss for you. We give you all the detailed info for repair, about your streams, optimize your process conditions, reduce unnecessary repairs, of course money saving, and we save your national resources. This is a case study from a tank farm in Italy. What they did, they detected around 20 valves that they were thinking that they might be leaking. So we did not did the full tank farm here. What they did was they took 20 valves and they thought they were suspicious. So what we started was we did around 7 safety valves measured, 10 gate valves, 2 control valves, and 1 brake plate to the flare. Before shutdown, we measured 2 leaks from the 7 safety valves, 2 leaks from the 10 gate valves, 4 leaks from the gate valve, from the control valve, and no brake plate was leaking. So in total, around 8 leaks. After shutdown, you see that they only repaired 1. But if you're going to see to the loss, before shutdown they had a loss of 250,000 kilograms a year. After shutdown, they had only 70,000 kilograms a year. Meaning, just by repairing 2 valves, one they fully closed, the other one was still leaking but was much lower, they reduced around 200,000 kilograms a year. So again, this is why we call it like flare management. You don't have to repair all your leaks. You can calculate leak by leak what is the exact financial loss, and you can then determine if you want to repair it or not. This is another full tank farm that we did, also from a refinery. We had around 89 sources in total, 14 control valves, 41 hand valves, and 34 relief valves. We found around 9 leaking ones. The leak rate was pretty high, so 10%. And again, the emissions were around 20,000 kilograms a year. Not so high, but again, small leaks become big leaks. So important to know to tackle your leaks when they're small in this case. So in this case, around 9 leaks you could be repairing before they're becoming very large leaks. Also, if we see emission per chemical product in kilograms a year, we just saw that we have been monitoring all kinds of flare points. In this case, we also can give you the exact loss on the products. You see here, for example, butane, the largest leak here was ethylene, around 40,000, so 75% of the full leaks was ethylene. The stream doesn't have to be 100% pure because the software can recalculate all the different streams, meaning if you have a stream, for example, 30% propane and 70% ethylene, it can exactly calculate the loss on this. Again, you get full detailed repair orders. You get a full report. So every leak, there's a picture. There is an overview of the PID. You got the number. You got the product stream. You got a localization. For example, 2 meters from vessel A, height 2 meters. So all the information that maintenance needs is there in the report. Of course, you got a full mapping of all your internal valves in your tank farm and all signalization of all the leaks. So all the leaks get a very colorful green tag so that you immediately know, okay, this relief valve is leaking, so you cannot miss the leak afterwards. Okay, this was the presentation. I would like to thank you for your attention, and I propose that we are going now to the question.
Thank you very much. Okay, so it's now time for our question and answer session. Audience members, if you'd like to submit a question, you can do this by using the questions widget. Simply type your question into the box at the top left-hand corner of your screen and click submit. But for now, I'll just move on to some of the questions that have already been sent in. Okay, so our first question asks, can the Sniffers support us in protocol setup and support towards local governments?
Of course, if we see in the presentation that the NTA was the protocol that's being used for tank emission monitoring in Belgium. And again, we can help everybody or every country with their own protocol or with their own legislation.
Thank you very much. Okay, our next question is, can the Sniffers operate globally?
Yes, of course. We have offices around the world. We have agents, so we have a large network. We work already in South America, the Gulf region, in Asia, around Europe. So we have no problem. We are very experienced in working abroad, so this gives no problem whatsoever.
Okay, brilliant. Okay, and another question. Can the Sniffers help us with a very specific scope of work? So do you help people with very specific scopes?
Yeah, what you have with tank measurements is that it can be a very specific question. All customers have different goals or different problems. And the first time we like to listen to the customer, what are they saying to us, and then we can really make a special program for the tank monitoring. This happens a lot, so this is not. Of course, we can specifically help them with their scope. Yeah.
Okay, brilliant. Thank you very much for that. Okay, so it seems that we have reached the end of today's Q&A session. So thank you very much to everybody who... actually, we seem to have another question that has come in. Just bear with me. Okay, here we go. So somebody wants to know if you have any experience in working in Mexico.
We did a Vopak site in Mexico already. I think it was around the East Coast. So yes, we've been there before, and also for tanks. So no problem.
Okay, brilliant. Thank you for that. Okay, so now I believe we have reached the end of today's session. So that's all that leaves me to do is to thank Bas and Lean for what was a great presentation, and the Sniffers for sponsoring the session. To our attendees, you will receive an email shortly telling you how you can access the on-demand version of this webinar. Or you can access this through our website, which is www.business-review-webinars.com. Once this webinar ends, today's survey will appear in its place, and we would appreciate it if you could take the time to answer the questions provided in order to give us a little bit of feedback. We look forward to sharing further webinars with you, so please do keep an eye out on the website just mentioned, and follow us on Twitter @BRWebinars for daily updates, and join our LinkedIn group, Business Review Webinars. Thank you all once again, and I hope you all enjoy the rest of your day.